Respected Director, Mr. Abdul Rasid Tokyo Shark Energy Center, expert of today's seminar, Mr. Manujashri Vasura Vijayasundara from Sri Lanka, distinguished participants from SARC member states and all around the globe, fellow colleagues from SARC Energy Center, good morning. Now we are having a webinar on the topic energy transition and circular economy, turning west into energy. Thank you very much for joining us today in this webinar. My name is Kiran Gautam. I am working as a program leader energy trade here at SARC Energy Center, Islamabad. Prior to this role, I was with the Water and Energy Commission Secretariat, Government of Nepal as a senior engineer. So currently I'm on deputation here. I shall be moderating today's webinar. The aim of WEES is to discuss on the energy transition, circular economy, where the role of waste to energy is very important. Dear all, we will have a presentation from our expert, Mr. Manujashri Vasura, followed by Q&A session. We may send in your question at any time during the presentation. We will collect these and address them during the Q&A session at the end of the presentation. With this, now I would like to request respected Sir Abdul Rasid Tokyo, Director, SARC Energy Center, for his opening remarks.
Thank you, Kiran. Good morning. My name is Abdul Rashid. I'm Director SARC Energy Center. So today's webinar we have on energy transition and circular economy, turning waste into energy. As you all aware, SARC SEC is the technical arm of the SARC Secretariat, and we have taken various interventions to promote energy security, foster renewable energy development, promote rural electrification, enhance energy efficiency, and build capacity of energy professionals of South Asian region. SARC region represents nearly 25% of world's population, and energy security and sustainability in an important agenda for the prosperity of the South Asian region. Ladies and gentlemen, I'm hopeful that today's webinar on energy transition and circular economy, turning waste into energy, will be fruitful and will help enhancing the knowledge of the participants. You are well aware that with the rise of population in this region, management of the waste has become challenging. However, we have come far away from the production of the dung cake to electricity generation and a power plant using waste. This webinar will focus on the growing role of circular economy in energy transition. It will explore how waste materials such as agriculture residues, industrial byproducts, municipal waste can be converted into energy, contributing to cleaner energy systems and reducing landfill pressure. Dear participants, we are privileged to have very prominent regional expert on this topic, Mr. Manoja Siri Bhasura, who has joined us today in this webinar from Sri Lanka. I welcome Mr. Bhasura for the webinar. We hope this session, with his guidance and his insights and expertise, this session will be enriching and encouraging for the participants. I thank you for everybody joining this webinar, and I hope this session to be interactive and fruitful at the end. And I now formally declare the session open. Mr. Kiran, Miss Kiran, you can take the session further. Thank you.
Thank you, sir. Thank you very much for your remarks and your valuable time. Now we will shortly start the presentation. Before the presentation, I would like to introduce Mr. Manujashri Vasura. He is an electrical engineer with over 20 years of experience in the electrical power sector, specializing in the development and implementation of large-scale power generation projects. He has extensive hands-on expertise in hydroelectric systems, engine-driven generators, gas and steam turbine generators, and particularly which matches to our own United Waste to energy power conversion technologies. And he has demonstrated proficiency in project execution, technical evaluation, and optimization of power generation assets. Currently engaged in the development of renewable energy projects, focusing on sustainable power solutions and the integration of advanced technologies and enhance energy efficiency and reliability. Contribution to the global transition toward clean and resilient energy systems. He has prior experience of working in Maldives and India in waste energy projects. So, sure, now the session is yours. I would like to request you to start the presentation.
Okay, Dr. Kiran, thank you. I welcome you all the participants to the this webinar, Energy Transition and Circular Economy, how the waste will be turned into energy. And before starting anything, I would like to give my thanks, our gratitude towards all the SARC members who have helped us, prayed for us, and then assisted us during the disaster. And thank you all. And before starting, I would like to say that all the supporting material and then all the technical detail related to this webinar actually is publicly available in the internet and the social media and the other media platforms. And the next thing is whatever all the ideas and the technical detail that is shared, my own experience and then the experience gained through the course of all the projects and all, and then those are shared among the other members who are in the teams and the other expertise who are working with me and in the other organizations, and those are shared. The sole purpose of sharing those things are for education and for knowledge sharing. And then I hope that this session will be truthful, and then I can give the insights and whatever the plus and then minuses of doing and then going ahead with this kind of energy transition that is in discussion. So in Sri Lanka, and then policy related uh, uh, scope of the webinar. And first, we'll move to the fundamentals. In fundamentals, there are three areas that I will cover. That is circular economy, and circular economy, how the circular economy is adapted in renewable energy, and waste, about waste, and waste to energy technologies. So, circular economy as defined, this is as per the European Parliament model. So, it's a model, economic model, where we use less and waste less, and still keeping on our normal economy, our finances, our functions going on. Make sure that there are three main pillars. That is to eliminate waste and pollution, and then circulate products and materials, and then regenerate nature. So in eliminate waste, that means sometimes you have to, it's a re-engineering process where you will eliminate certain processes. So eliminate certain ways how we do things to reduce the waste, and then in turn the pollution will be reduced. Or what you can do is this any byproduct, any waste material that is generated can be used in another process where it will give higher or maybe lower economic value, but still it will go in the same economic model. Then same way the 3R concept, you reuse them as much as possible. Then next is regenerate nature. This is where the sustainability or the long-term perspective of the circular economy comes into play, where we allow the nature to take care of has been there for the entire time, which means that we let the this nature repair itself. Or let's say, like, if there are some waste, if there is something that we have to waste out, what will happen is we will let the nature take care of it. So that is where the raw material and the recovery is happening. Okay. So then next key point is if my voice is not clear, just inform. I can slow it down and then rephrase.
It's
Okay.
okay, sir.
It's okay. No, okay. So last point, which is very important towards circular economy, is one we call driven by design. That is one of my colleague from a previous working place who actually got involved in the waste power project development. The phrase she was telling is do better before. It was a common phrase she was emphasizing and telling. So it's about this. See, whatever we do, we don't wait until the end of anything to do something, do the corrections. But instead, we do it at the beginning. We see, we plan, and then we will project. And then afterwards, we will design it in such a way that it is adapted in the model of circular economy, where we can reduce waste, or where we can, how we can change certain activities, certain things that we do to eliminate or reduce whatever anything that bad can happen, or maybe we will do it completely different way. So this is what is called driven by design, or do better before. So we will be, everybody will be at a better position to start things and then design and plan it, and then at the end we will get a better product, better result, and then better service can be given. So this is the basic idea of circular economy, and then how it is done. So next is circular economy, how it should be incorporated in renewable energy. When we discuss, basically the renewable energy is main pillar, main supporting function of circular energy, because renewable energy, this last part, this regenerating nature, elimination of waste, and then all the things are supported by renewable energy, because we are general our other the matter in discussion is the transition. So transition is we will be transition our energy sector from fossil or the linear model to a circular model, where we are adapting the regenerative or renewable the energy sources that are getting renewed, which are not affecting, the limited effects on the nature. So still, when we take renewable energy as a different sector, or when we separate it, but it may not be fully adaptable within the circular economy model. Where for when we take examples, certain like PV, these panels, what are we going to do with the panels when the life cycle is over? In process, what we can do is we can have a better product to have enhanced lifetime. That is one thing that can be done. Next is when we take wind turbines. What are we going to do when it is decommissioned? What is our plan? So same thing goes into the hydro and mini hydro, those things. So this is where we have to focus more on recycling and reusing, and then whether those things can be used in a next project that is coming on. So that circular economic model has to be fully adapted within renewable energy sector. Otherwise, even though the renewable energy sector supports circular economy, it won't be a sustainable solution on long term because renewable energy itself will be a downforce towards this circular economy. Now let's come to waste and waste management. So normally what the basic principles that are adapted in waste management is reduce, reuse, and recycle. And here this waste it comes into a few different stages, like household scale, and then small businesses, and then industrial, and then mass scale. So what happens is we can focus on reduction or elimination on small level, like household and then small business or other institution areas. But here, what has to be focused mainly on large scale or mass scale waste and waste management, because of course, I mean, we have to start from the very basic steps over where the waste is generated, but still the primary focus, primary issue or the large scale results can come from the large scale or mass scale management, because it's all about economy, how the circular economy can be adapted. That is one side. The other side is finances, because when it comes to the large scale, it's basically it becomes economic for certain things to be implemented at the end. So that's why this waste and waste management will focus on large scale. And next is why waste and waste management is very important is a third factor, that is for all this production, all the recycle, even if you take recycling or reuse anything, energy, manpower, and time spent is spent. There is no recovery of whatever the energy and manpower and time spent on getting the products and services for human use. There is basically no recovery. So that's why reducing or elimination of waste is very important. That along with that, what that is wasted, but we are not only wasting material, or we are not only wasting what is available around. That is the energy and manpower and time, which is irrecoverable at any cost or at any instance. So that's why we have to mainly focus on these circular economic models, waste management, and recovery and all this, because there are things that we can never recover. Those are, one is time. Next thing, those things are there. And when it comes to mass scale waste management, what we do, easiest one is landfills. You just dump it. Wherever you dump, you can just call it as a landfill. But organized landfills, that is where you have proper cover for this ground preparation, big area, and then management techniques, and then transportation. Let's say it's little far away from the pollutant areas, or they have adapted certain techniques to minimize the other pollutions that can happen. Those are the managed or planned landfills. That is also one acceptable and adapted way of managing a large scale waste. Then it's the incineration. You just burn it. That is the other easiest way. Whatever that can be burned, you burn. So incineration, what is discussed over here is incineration that is a controlled combustion. It will be done within a chamber or within a controlled environment where it will be fully burnt. I mean, what we have to understand is when we burn, it will just burn. We don't know how far it will be burned. So this incineration, when it comes to incineration, what we focus is on complete combustion, turning the hazardous or waste material into a safer material that will eliminate issue with having waste collector. Then it is waste to energy. So waste to energy, this is where one important or one key factor with waste to energy. So waste is there. So waste comes with the different characteristics. And what with waste to energy, what happens is that irrecoverable energy can be up to a certain extent we can recover the energy. Oh, that is one factor, or else we can in certain technologies we can turn them into a useful output as well. So now let's go into discussion on waste energy. So what happens in waste to energy? Waste conversion into energy is what we do is we will recover the energy and then we can generate energy, and then there are types of energy plants which I will explain shortly. So energy recovery is, see here, first I will tell what are the different types of waste to energy plants. It's one is incineration related energy waste to energy plants, and that is where you have the primary function of a waste to energy plant is to manage waste. Energy is a byproduct. So therefore, we have to focus on waste management. So incineration is one technology used for waste management, where you burn it in a controlled condition, as I previously explained. Then what happens is, when you burn, what you get is gas and heat and some ashes. Heat is one very useful form of energy. So that energy generated in burning or incineration, that energy can be converted into the useful energy, which is typically in our this South Asian region. But the useful energy that is required, that is very versatile for us, is electricity. So when there is heat, we can convert that into electricity using steam. So what the technology that is adapted in most incineration and incineration based waste to energy plants is you have a burner or a incinerator that is coupled with a heat recovery boiler, and that boiler generates steam, and then steam is then converted into electricity through steam generators. That is basically what is happening. And the next type is you use this biochemical processes to handle the biodegradable waste, that is mainly food waste and other waste that can be subject to biodegrade. So there, the process is you use biochemical or biological treatment plant, and then you generate mainly methane. Then methane is a gas that is combustible. That methane can be used in different generation areas, like it can be used for power generation or it can be used for heating purposes. There are various, once a useful output is created or generated, energy source is generated, it can be used on various areas. It's all about having the source, having the generation source. Other two main areas are this the gasification and pyrolysis. Both are in a sort of similar form of technology, where in gasification again you will get a gaseous burnable gaseous output, and pyrolysis also the same. And what matters there is the technology used for in waste to energy plants are different from the source of waste that that will be using within that plant. So that there may be in a certain area we may have two different types of plants. So two different types of technologies can be adapted in one single plant. For example, you can have incinerator to incinerate whatever the waste that can be burned. Next is you can have a parallel to that, where if you have separated the biodegradable waste, you can use it in a biochemical reactor, where you will get methane or a burnable gas to be again used, maybe the same generation setup or a different generation setup, where you will get a useful output. So here in mostly within our region it's electricity, but when it comes to industrial area or a cold country, what would be their useful energy would be hot water or steam directly into the either to space heating or ground heating, that kind of a useful area. They'll be able to use the generated energy. So when I go to this energy recovery and energy generation, actually especially in heat recovery generation, incineration, it is the waste heat that is generated by the incineration process is used in energy recovery. So it's mainly energy recovery. So whatever that is wasted is being recovered as energy recovery. And then energy generation, that is where this methane or other gases that is produced, and then it can be processed, and then you can be used on directly on energy generation. I mean, when it comes to energy generation, it doesn't have to be electricity itself. I mean, the common misconception is energy or energy generation power plant. Whenever we say that whatever our idea goes into electricity, it's not only electricity. It has a lot of other areas where any fuel that is generated or recovered within these facilities could be used in transportation or any other facility that we use. That is feasible as well as required by the society. Next, this is a basic. I will primarily focus on incineration-based waste-to-energy power plants. This is a typical diagram of a waste-to-energy power plant, where the key function is to incinerate, then heat recover, and produce electricity. So this left-hand side, that is where the material or this waste for public and for the management, it is just a waste. But when it comes to a plant, it's a material, it's a resource, it's a raw material for this particular plant. So that is why this waste or what is not commonly, I mean, it's used as material, because once it is delivered and then slightly processed for some time, then it becomes fuel. It's not waste, it is a fuel that is powering up the power plant. So that is how the terminology works. So how it happens is, I will briefly go through the waste to energy plant process. So in the dump trucks, preferably dump trucks, they will deliver the waste into a bunker. This bunker is a very big tank where it is sealed, and then this waste is being kept for some time. Like generally in our case, what happens is we have to keep the waste for about 3 to 4 days. We call it fermenting process. What happens is this since the waste is mixed, there is burnable waste and then biodegradable waste, both are there. So we allow the waste to be mixed and then kept there for like 3 to 4 days for fuel conditioning. What happens is the additional moisture, additional water will be drained out during that period. Also, due to the microorganisms and then these bacterial activities, what happens is this biodegradable part of the waste will be slightly fermented or slightly conditioned so that it will become a fuel at the aging process for 3 to 4 days. Once it is done, then it is mixed. That is, mixing is done for making it homogeneous because our waste, wherever the waste is collected, it's not homogeneous. It is varying from one drum truck to other one to day, it varies. So make it homogeneous, it is mixed. Once it is mixed, it is for feed into the incinerator. Here, this is where it is dumped. This is a mixing or the feeding train. And this is where it is fed into the incinerator. Once it is fed into the incinerator, this is this part is the incinerator where the combustion happens. It is very important that this combustion or this incineration is a controlled process. There are certain conditions that we have to maintain to make this combustion safe for the environment. Generally, the advice is for the public is that don't burn waste because it can generate harmful gases. Generally, it is these dioxins and furans, which are carcinogenic. Those are very bad for people as well as any creature. It is very bad. So if we inhale. So we need to avoid that within this chamber. So what we do is the typical technology is that we have to maintain minimum of 650 degrees Celsius temperature within this chamber, and then this burning process, so incineration process, has to go for at least 2 seconds to burn convert the dioxins and furans into safer compounds. So that is achieved by this turbulence created within the chamber. And once it is done, it will move to this heat recovery boiler. And from the boiler, the hot steam is created, and then power generations happen here. Then comes the other part of the waste to energy power plant, because this is now the fuel is a biofuel. Biofuels, it's like wood. We can consider this is as wood. What is feeding is wood. With wood, it generates ashes. So there are two types of ashes. One is bottom ash. It's like our normal household cooking. What is left after burning is bottom ash. What is on the bottom is called bottom ash. Then the fly ash. But fly ash is a lightweight, small particle ash that with the flow and with the flue gas that will go up towards the atmosphere. But here, since this is a chamber, what happens is it will go up, and then those fly ash will go with the flue gas and then come into this area. This is called the flue gas treatment, because the flue gas has to be treated for two main things. I will come to that. But before that, let's discuss on this bottom ash. So the bottom ash will get collected this area where within the chamber. And there are other things that comes because there are some waste material that cannot be burnt. Generally, typical ones are this construction waste. There we most of the time we get these bricks, parts of bricks, cement, and these parts of concrete, iron pieces, especially glass and household utensils. Those things are common item in this waste that typically we receive from municipal areas. So that is collected over here. And the bottom ash is collected, is comprising of ash and unburned material and whatever that comes on a residue in the burning process. Also, due to the turbulent maintained within the uh, incineration chamber, part of the ashes move up and then which has to be part of bottom mash will get and then collected within the other areas where there is less turbulent or where there is uh, resistance. So all the things will come as uh, bottom mash. Then once the fly ash, when it is fly ash, this is where it is collected in the flue gas treatment. Flue gas treatment, what is done is the small particles, small uh, ash particles are collected within this because once you burn, if there is any polythene, plastic, or that sort of a material, burning will generate acidic gases, especially this sulfuric and then HCl. Those gases will be chloric gases will be generated. And here we this spray tower or treatment tower, what happens is we inject calcium hydroxide or calcium hydroxide to neutralize the acidic gases. And the other purpose is at here the temperature of the gas will be over 200 degrees. Even after recovering the energy, it will be 200 degrees. So we have to reduce the temperature of the flue gas to meet the criteria in the this recovery. Sorry, this bagged house or the bag filter. And the other thing is this emission. There is a temperature which we can emit the flue gas. So to serve the purpose, those things are those technologies, those methods are used. So there's a slight small video that explains what I have told. It comes here. I will play the video. Okay, so that is basically what is in brief what happens in a waste to energy power plant. So let's discuss on waste to energy. How important this waste to energy in a circular economy. So what happens is in a waste to energy power plant, any type, what it does is it converts the waste into usable energy or usable output. And next thing is landfill, reduction of landfill for the betterment of this entire process. In a waste to energy power plant, what happens is the volume or the weight of the waste is reduced up to at least 1/10 or 1/7 of the original capacity, because the ash is roughly 1/7 or 1/10 of the original waste that was delivered to any particular area. So the area that we need for waste dumping will be reduced. So that's why this landfill use is less when we adapt waste to energy technologies. Then the other thing is promote resource efficiency. This is where the separation or the segregations are enforced, because when it comes to waste to energy, if the plant is accepting only biodegradable waste, then there is a tendency, there is a forced action coming into play, where the people or the municipalities or whoever is handling the waste is requested to deliver only one time. So then what happens is it will focus on that sort of a process where it will enable the resource efficiency. Then the other subject is energy transition. That is the energy transition towards the renewable energy. So decarbonization is a one major factor with waste to energy on two areas. Like, see, what happens is if we don't generate energy using waste, same amount of energy has to be generated elsewhere or with using other resources. If it is a renewable energy, good. But most of the time, what happens is this balance of energy is generated in all around the world using fossil fuels or non-renewables. So one area decarbonization is supported with this waste to energy is by replacing the typical this conventional fossil fuel based power generation or energy generation. Next is when we dump waste on a landfill or maybe for irregular or unplanned, unmanaged dumping, what happens is this fermenting or the biodegrading process will generate methane. Generally, methane and those related gases that are generated are 20 times hazardous and 20 times effective than carbon dioxide when it comes to greenhouse effect and then other pollutions to the environment, and especially to the atmosphere. Other than having 20 times damage, what decarbonization, what happens is this methane is captured. Methane is either we don't allow the methane to be generated, or whatever the methane that is generated is converted into a safer compound, that is carbon dioxide. So that is how this process enables the decarbonization. And then since this waste to energy power plants, those are it's a it's like wood. When you burn wood and then have a power generated, the power generation is, we can maintain it up to certain consistent level, even though there are fluctuations. It's not like wind or solar. So it can support base load or a stable power generation capacity, and then it enhances energy security. See, I will tell you one example. During this energy crisis 2 or 3 years back, we faced in Sri Lanka. This power plant, even though it's a small amount, only 10 megawatt that we have generated, but still that 10 megawatt was one important supply during that time, because there was that time there was we had issues with fossil fuel based energy generation. So it will enhance, it will enable energy security within the energy sector, because waste is already there. We have the process in generating waste into energy. So now let's discuss on global and South Asian context towards energy transition. See, when it comes to waste to energy, European Union is a primary leading area, where leading countries that adapt this waste to energy technology, and then they have developed, and then they have gone through a lot to managing their waste as well as meeting their requirements, especially for industrial purposes, as well as this town and country or this heating purposes using waste. But in European countries, the waste type, or the type of waste is uh, slightly different from what we discuss within SAARC region. And Japan is a very special case. Japan, they have high strict standards, and then it has to be separated, and then having this dumping waste is completely prohibited. And then they have even small municipalities, small villages has to meet with the required standards on waste management, and so that they have to adapt waste to energy power plants on different scales. And then they have, sometimes they have gone even further to like 95% recycling of material, because certain areas they cannot move with waste to energy. So they have gone a further step. Japan has gone on further steps on meeting the required standards. And China, they have different scope, because China, there is the amount of waste generated is very large, and then the composition of the waste is also varying from area to area. So, and then industrial waste and municipalities, it comes in different way. So they have adapted large scale waste to energy power consumption conversion to meet their waste management needs. In turn, they are getting energy as out. So when in global scale, we, even though this generates energy, we cannot omit the concerns over emissions, even if we are burning waste, and then if there are bad emissions, because there are emissions, we cannot avoid it. But if it is controlled, if it is not efficient, then it does not support the required, this circular economic standards. If we have to burn and then do another sort of a destruction, is not acceptable. Then, as I explained, what Japan has done, we have to go ahead with waste segregation. Once it is segregated, certain things may not be waste. It is definitely going to be a raw material or a usable part or a product in another area, or maybe in the same process. So waste segregation is very important in managing with the waste, as well as in the waste to energy plants, because waste to energy plant, if it is incineration, we have to limit as much as possible of this biodegradable, because biodegradables can be used in another technology. But still, if the plant design supports certain amount of biodegradable and moisture, then we have to maintain that conditions. But still, if we can limit the biodegradables, it is very good. Next thing is this non-combustible waste, especially construction material, glass and iron, that has to be separated so that the waste to energy power plant will benefit in a way, because whatever is not burning will consume the heat created over there. And then next thing is it will have end product, that is by this bottom mash contaminated with whatever the unwanted material. So we are shifting from one place to another one. So that's why this waste segregation or separation policy and then implementation is very, very important. Next, when you come to South Asian status, it's India being primary in waste to energy. They have actually they have had about 15 waste to energy plants in operation, but now there is about 11 that is in operation. There had been several like technical as well as practical issues in certain waste to energy power plants being either implementation or maybe in operation because of various issues. And we'll go through in certain things in time if time permits. And then Pakistan, of course, there is high potential, and then they're in initial stages of development, and then it can be done. And there is about 500 megawatts of potential as the studies reveal. Bangladesh also have two plants in operation, and then several in development stages. Maldives, actually, they also have no other option other than going into this kind of a waste to energy power plant, because what they have been doing previously was to get the waste they collected and then dump it in a one island. Now they have run out of options, and then they have to move. They cannot be doing. I mean, even everybody can't be doing what we have been doing for several ages, which is a bad practice. We have to move forward. That's why Maldives, they have actually taken the initiatives, and then it's in development stages, and probably it should be implemented and then in operation within the next couple of months. Nepal, actually, they also have methane production, that is biodegradable waste management. And then finally it comes to small scale electricity generation as well. Now, when it comes to this case study, this is the 10 megawatt power plant, waste to energy power plant done in Sri Lanka, which is having 700 tons of waste processing capacity per day, and then generates 10 megawatts of electricity. Actually, this is the 10 megawatt output. Internally, it generates about 10 to 12 megawatts, and then balance 2 megawatt to 2 to 3 megawatts is internal consumption for the plant usage. So useful effect output is 10 megawatts. And this project started in 2018 and completed by the end of 2020. And the owner is Aitken Spence. It's a group of companies, PLC. And main stakeholders are Colombo Municipal Council, because this is mainly focusing on managing municipal solid waste that is generated in Greater Colombo and suburbs. And Ceylon Electricity Board, that is the utility provider in Sri Lanka, because the electricity generated is connected directly to the national grid. So electricity board comes in two ways as the one stakeholder, that is they buy the electricity is connected there. Sorry, is there an issue with sound?
No, sir, we can hear you clearly. So,
Okay, sure. So, Ceylon Electricity Board, the utility provider, comes in two areas. That is, whatever the generated energy, they will absorb into the national grid, as well as that is they pay. That is where the finance, so the economic activity happens, the generated electricity is paid. That's why it is one key stakeholder. The municipal council being the supplier, that is the waste supplier, they will give the fuel to the power plant. Annually, waste, this is 2020, 2021-22 data. Generally, about 250,000. Sorry, there's a slight mistake. It's 265,000 metric tons of waste was processed within a year. Estimated annual energy generation is 80 million kilowatt hours. That is 80 million units. And initial investment was about 80 million US dollars. When it comes to tariff, Sri Lankan this currency, it was varying because of the exchange rates were different. So the achievement, when we say achievement, this is the first waste to energy power plant to achieve commercial operation in Sri Lanka. There were actually 5 plants were licensed to start. One is this 10 megawatt one power plant. Next one was there was a 12 megawatt one plant which is with dual line. That is, one line is for incineration, the other one is biochemical processing plant, which is a combined generation is combined. So it finally the plant capacity was 12 megawatt, but due to certain commercial issues, it didn't work out. And the project started, real one actually started somewhere around 2016. There was a disaster happened in closer to Colombo, where there was a dumping area. The waste dumping area got collapsed, and then several houses were damaged, and then a lot of people died. So that was the initiating triggering point where some proper the solution has to be given to the waste issue in the Colombo area. So once it is initiated, and then technical support and financing, and afterwards 2018 the project started, and then by 2020 the project was completed, and then after a 3 months trial operation, it was fully in operation. And 3 years this project was operated by EPC contractor, which is a Chinese contractor. And then now this plant is fully operation by Sri Lankan company and the Sri Lankan people. Actually, this was planned to complete within 18 months, 18 to 24 months from the start, but there were 2 issues. Like 2019, there was a tragic incident, and then afterwards, that delayed the process, and then we couldn't meet the target. Afterwards, after like 6 to 8 months down the line of recovery, then the COVID-19 pandemic strike. There was a delay, but still, even within the COVID-19 pandemic, we managed to go ahead and then complete the task within a year. Then commercial operation, and when the commercial operation was underway, and 2022, Sri Lanka faced this economic crisis. With the economic crisis, both the source, that is waste supply, as well as the buyer, that is Ceylon Electricity, both were affected, and then the middle part, the processing plant, was affected both ways, like the supply as well as selling. So there was a serious issue with the finances. So then when it comes to technical challenges, this location, strategically, we have to locate the plant. So it was placed closer to the load center, that is where the waste is generated. Like it was about 10 to 15 kilometers from the main city. So placing it in an urban area was a challenge, but still there was a designated industrial area which was given, and then it was location was okay, so that the issues with the location was limited. But when it comes to waste to energy power plants in all over the world, it's generally the perspective of waste to energy plant is not very good, because it's you get waste and then it smells, and then the idea, okay, there will be toxic things that they will give out. Those perspective of waste to energy power plants are not good. So what they do is, generally, if you search on Google search on waste to energy power plants, the waste to energy power plants are like very nice structures. It's like a hotel. I mean, that is how you maintain the image. That is one. Next thing is, within the plant you maintain very clean and then hygienic conditions, and then access to people don't just access into the areas. There'll be protection, as well as it will be covered, so that the required isolation is provided within the plant to the working, I mean the staff, as well as anyone who is visiting, as in most importantly for the dump trucks and any person who is coming for inspection. So that is a challenge. I mean, that is not generally a part of other typical power plant. Then next thing is data availability. There's a serious issue with data availability that is in relation to waste, because now there is in Sri Lanka, now there is, because of the plant and then the other implemented tactics, but still data availability are different, because whatever the data that is captured within the systems, that is by municipalities and collecting agents at the power plants, dumping areas, this landfill locations, they collect data. But whatever that is dumped elsewhere, whatever that is done out of the radar, is not captured. So when we do a plant design and planning, the data that we are getting is not the real data, because we faced that issue. Initially, it was predicted that there is about 1,000 tons of waste generated per day. But when we start to get the waste from certain areas, it was completely different. And the other thing is the waste composition changes. We to do accurate plant design and then come into this output. The issue is waste composition, and the other thing is moisture. Moisture varies from time to time. This certain sometimes if there is rain, it's like 50% of the waste that is dumped is water. So those are there, and the other thing is there is hazardous and then hospital waste is a part of normal municipal waste. When it comes to scheduled industrial waste, okay, we know because it comes from this place, and then these are the types of waste it is there. Then these are the things that we can accept, or these are the things we cannot accept. But this project is mainly focusing supporting the municipal areas. There is in hazardous as well as medical waste within the waste itself. So that is a concern, because we won't be able to meet the required standards. And due to this availability of hazardous waste, especially heavy metals and plastic content, this advanced emission control and then flue gas treatment facility has to be adapted, and then it's kind of operation and maintaining that is a big technical challenge, because it's a continuous process that we have to maintain, because otherwise we'll be again on the same place, because we'll be burning, and then finally what we will get is a bad output. And the other thing is water usage. We used canal water nearby, and then during the drought season, the water salinity is high, and then we had to adapt another this RO technology to do that. Then next thing is air cool condenser is used to limit the water usage for this thermal power plant. We need water for cooling. So as a circular economy adoption, we have used air cool condenser. Otherwise, what this typical type is to use a water cooled or a water cooled condenser, which will where the water consumption will be very high. So with this one, we have limited the entire water requirement to 6 meter cubes per hour. So that is the maximum water needed for the plant. And the next thing is leachate. Leachate treatment. This is a special part that is not available within European or Japanese plants, unless otherwise it is municipal waste that is non-segregated. Leachate treatment, this is the part that address the biodegradable and the moisture content of the waste. So what really happens during the rainy season is this capacity is um, not enough. This is designed for the moisture and the generated liquid part of the waste, but what the power plant would get is more water than the waste. So the capacity will be compromised. What happens is when there is high moisture, the output of the power plant will drastically reduce because the waste heat generated in the incinerator will be used for heating the water within the chamber. Then other challenge we had was this is the first power plant in Sri Lanka. So the technical know-how and the experience in operating and maintenance was a challenge. But they were trained, and then competency was built up during the 3-year operating time. The last issue was ash disposal. This bottom ash disposal can be done, but still being the first of its kind in the country, there was lengthy process of getting the approvals and then testing, using, and then everything has to be done for the first time. So it took long time to get a process on bottom ash disposal. Fly ash disposal, it was planned from the beginning. It is planned to solidify the this ashes using chemicals and cement, and then it has to be securely stored in a landfill. So the landfill that is purpose-built landfill. So that's a different part. Part other than this project. So how we have adapted the fundamentals in the related case study is the design. So there are key things are this three factors. One is water use. Water use, that is leachate water. Leachate, all the water that is treated within the leachate facility is used back in general use like gardening and then washing. Those things are not for human consumption, but for especially for gardening and the other required ones. And then adoption of air cool condenser has drastically reduced the use of water, as well as whatever the water that is used in a condenser or a air cooler cooling is become waste, and then that water has to be treated. So that has been eliminated. Then location, we have the plant is located closer to waste center as well as electricity demand center. That is Colombo city's area is the high demand electricity consumption area as well as waste generated. Also, this plant cater to entire western province. That is it's like 50 times the area that we have originally planned, that is the Colombo city area. So this other municipalities that are located within the area, like 50 to 100 kilometers, maximum of 100-kilometer radius, all those municipalities deliver waste into this facility, so that it is strategically located. That will minimize the cost or the fuel used in transporting the waste, as well as, since it is load center, the losses in the electricity distribution is also reduced. Next is energy transition. As I explained earlier, this was a shift in energy from this fossil fuel, but still, I mean, when we get energy mix, it's a different scenario, because when we check this energy related electricity generation related data, daily one, what happens is this is about less than 2% energy that is generated within a day, but still that is a good start, because in Sri Lanka, this typically at the peak of generation, renewables sometimes hit 70% of daily generation. So which is a very good thing. But out of that, 2% will come from this plant. So then next is legal and regulatory challenges, because it's typically this waste sometimes become a, we call it a mafia, or a very, it has all those unwanted associations, because certain types of waste, certain types of waste has economic value, as well as, since there are restrictions, it becomes a cash cow for some other people. So that has to be generally handled over legal and regulatory framework. So the waste collection basically is local government responsibility, as well as there are private parties who do it. And we can enforce environmental licensing compliance. We call it environmental protection license here. That is environmental compliance. When you enforce that, then it will support the other functions, like proper collection if it is required to be segregated. And then now what has happened is, most of the industrial sector, even small businesses, they separate and then send the waste to this facility, or there are another 2-3 small incineration facilities within the area, just because the environmental compliance is enforced. Without a proper certification and proper process of waste management, they are not given the environmental compliance licensing. Without that, they cannot operate. So that is a kind of a regulatory, not actually challenge, way forward that has been done. And misuse is a common factor. And then violation of environmental standards, we go and dump in waterways, which is a very bad thing. And political influence, and then sometimes concerns over human rights will come into play. Okay, this is not good, and then they can't do so. Those kind of human rights concerns can come, but actual human rights is that we don't pollute the environment. That is the real human rights that should be in concern. Then approval process, it was hectic and then very long process, because since it is being the first one, that is, but even for the other things, and now the processes are there, so that it can be implemented very soon. Financial challenges, it's the capital cost is very high. Generally, a typical 10 megawatt power plant should not cost more than 20 million US dollars. That is the typical rule of thumb. But this is 80 million. This is because of the technologies and the other requirements that has to be done. Because when it take the waste dumping pit, or the waste pit is fully sealed concrete tank which has this sealed cover, sealed area with it is kept under vacuum. So those maintaining is high capital cost. And the next thing is, so this O&M is a one key factor, unlike other power plant, even though the waste that in this particular case, waste is delivered free of charge. So there is no cost on waste or the fuel. But still, the one tariff, this actually higher tariff at that time. Even at with that, the tariff, 1/3 of the tariff is direct operational cost, and then other chemicals, and then handling of ash, handling of other byproducts, especially this handling of leachate. That is a cost that is in addition to this. And next thing is the techno-commercial operating model of this plant is the money, this cash inflow is based on energy generation, energy generated and exported. It's so if the techno-commercial model can be shifted other ways, like the supplier, the waste supplier, or the municipalities, if the municipalities are charged for the amount they dump, then there is cash coming in to this processing plant even before the real process is done. So that will enable the operating feasibility. Can come into that again. And then I told you this perception on this waste to energy power plants is very much minimal. It has a very low location, very low status, because the idea that, okay, it's on pollution fears. Even in Sri Lanka, there was an issue prior to this for this landfill, a planned landfill in like 100, like 200, sorry, 150 kilometers away from Colombo towards this north area. It's a far area, but still there were public resistance. Don't take Colombo waste to us. Keep it there, dump it there. So those are the slogans. So that is one sort of a resistance that public will have. That is one is because of education. I mean, they are not communicated properly. That is one thing. And then when it comes to waste composition, waste separation is it's a very important thing if it can be done, but it's typically not done. I mean, there were so many projects, so many activities done within the municipalities, and then they have succeeded up to like a certain extent, and then they have continued to do, but still waste separation is a bigger challenge in operating the power plant, because we get non-combustible items, especially metal, glass, and construction material. Especially the construction material, what happens is this incinerator bottom, this combustion chamber, there are some metal parts, that is moving metal parts. It's a moving bed. So that metal parts get damaged, or sometimes wear, and then there is high wear out, and then the bottom ash get trapped, and then it becomes, sometimes the process has to be stopped because of these unwanted things. And policy recommendations, see this a waste to energy power plant in waste management, it's not a standalone solution. We need to have different type of waste to energy power plants and landfills and waste management, other techniques combined in a circular economic model and implemented to these things to be successful, everything to be successful. So it's not one area, so that waste we should not address waste as a waste. It should be addressed as a part of circular economy model. Then next what we can do is to go ahead with national policy, and then financial incentive is a one key factor to waste management. And the other thing, when it comes to financial incentives and then methods, why people dump unwanted stuff. For example, batteries. I will tell you the story like this. People throw batteries and that contains heavy metal. Why they throw batteries is there is no proper way of dumping them. They don't know. It becomes a burden for them. So we need to have a method, if there is a policy or a method to collect those things, collect the batteries, and then once it is collected, it can be further processed because it comes with economics. Because if there is a lot of, adequate quantity, then it can be easily processed. So what we need to have policies and then activities, frameworks to collect them, and then it can come with financial incentive where okay, we can pay you like some amount of money towards to the consumer. Okay, you return this and then you will get this. And next thing is implementation of standards. Two more things. Then consumer or the customer responsibility and manufacturer's responsibility. Those two will support this the CE model. Why consumer responsibility is that we are implementing uh, this polythene or this plastic packaging. So that cost will be cost has to be mentioned and then incorporated within the product, so that when there is a financial burden on those kind of pollutants, the customers will either use different way of packing, or they will use other means of doing that. Next thing is manufacturer's responsibility and then cost recovery, because the cost of recycling or cost of managing the waste from a particular manufacturer. Let's say it's a bottled drink, so that if we can identify that bottle is there, so that the manufacturer has to pay for that one. So that's the cost. So either the manufacturer can pay the cost, or they can be responsible and then adapt proper policies, proper manufacturing or different material, and or have a process of reusing to meet the required standards. Those are the those how we can cover up the circular economic standards when it comes to large scale or country scale. Next thing is Sri Lanka is a very small country being compared to the other SAARC area. So we need a regional cooperation in meeting these all the areas, because this is one. Actually, we are sharing information, sharing knowledge, discussions, and then coming and observing what is being done, use benchmarking, and then follow the best practices. That regional cooperation in South Asia, in this area, is very much important, so that not even one other parties will also benefit, because Sri Lanka being a smaller country, I mean, for suggestion, I mean, certain byproducts, if it can be processed, like especially this collected batteries, for example, if India or Pakistan or Bangladesh, if they can process, if they have a capacity or a plant implemented, sending it there and then getting it processed will benefit the entire region. And waste to energy can be a part of national energy mix, but Sri Lanka case it's slightly different, because our potential energy generation in waste to energy is slightly less. But when it comes to India, Pakistan, and Bangladesh, it's at a bigger scale, like it's in 500, 600 megawatt scale. That will have a better transition support from fossil fuel to other energies, and then it can secure. No one has to, as a nation, no one has to be relying on fossil fuel, but instead you can use your own ways to own sources to generate the required energy. So with that, I conclude the session. So we can open for question and answers, any available.
Thank you very much, sir, for your detailed presentation. We have learned so many things. I was thinking this in a simple way that we were not used to manage our municipal waste. Why don't we generate from electricity from this? If there is a technology, but to generate electricity from waste is also a very, very challenging task. I knew from your presentation. So I would like to open the floor to dear participants. Now you can put your questions in the chat box or raise hand so that we can allow. Okay, Mr. Madha, you can put your question. Hello, do you hear us?
Please turn on, please unmute yourself. Or unmute. Mr. Madhav from the Nepal. Can you hear us? Please unmute yourself.
Maybe we'll take question from Additional Secretary Mr. Ali Reza, and then we'll come to Madhav.
Hello, good afternoon.
Good afternoon,
Hello,
sir.
can you hear me?
Yes, sir.
We can hear you.
Okay, so, that's a very interesting discussion we had this morning. First of all, I'd like to express my thanks to SARC Energy Center and then our esteemed speaker, Mr. Bahasura, for your very comprehensive and wonderful presentation. Though in between I missed a part of the talk, I was in a little discussion with my colleague in a different place. Anyway, so my question is that the nature of waste depend on country context. I mean, the waste in Singapore is very different from the metropolitan municipal waste in Bangladesh. So now we talked about different technology like incineration and other technologies. So, so when we will adopt or decide on a particular technology, what are the things of the waste we need to consider? I mean, what are the criteria we should actively consider before taking decision on a particular technology? So this is a very straightforward question for our respected speaker. Thank you.
Okay, Mr. Ali, okay, now see, first thing would be to identify on what type of waste you are going to process. That is like if it is municipal waste or industrial waste, or whether it is hazardous waste. So when you segregate those two, that waste type, then when it comes to industrial waste, it is typically industrial waste is we have to separate the hazardous part or a scheduled part. If it is industrial combustible waste, then it is straightforward. We should be able to go for incineration based power plant. But the case it's little tricky when it comes to municipal municipal solid waste. Then to identify what type of incinerator, what type of waste to energy plant we need, we'll have to go with the amount of waste that is generated. Especially in any case, we need to check on the amount, because amount has to be economically viable. Like there should be at least 350 to 500 kilogram tons of waste to initiate this kind of a project. Otherwise, it's not economically viable. Next is you need to go with the composition. Like in Sri Lanka, Pakistan, India, Bangladesh, even in China, when it comes to municipal waste, it's mainly this biodegradable part. That is what we are getting. So if there is biodegradable part, then we have to do again the quantity, and then the composition. If we can get the composition of that one, if higher composition is higher than like 40% of the waste is biodegradable, then we can go for with the bio related, that is biochemical processing technology to handle that biodegrading waste, and then balance can be used in incineration. But when it can come to practical, what we did over here, we use incineration technology for both. That is in the design. That's why this leachate treatment is adapted, where it can handle the bio part, and then the certain reduction in moisture level, and then it is treated as normal biomass fuel. So selecting the technology, first thing is the quantity and the type of composition of the waste that we are going to handle.
Okay, thank you very much. Thank you.
Okay.
Mr. Madhav from the Nepal came. We allowed your mic, so you can please turn on your mic. Unmute yourself. Madhav, can you hear us? Unable to unmute. So
He can type, then we will read and answer the question.
I unmute. So he may have a
in the
difficulty.
meantime, I think you have already told, but what is the cost of per megawatt? The production
Sorry?
cost of what is the cost of production per megawatt?
Cost of production per kilowatt hour,
Okay.
it was somewhere around 12, sorry, it was somewhere around 12 to 15 rupees Sri Lankan. That is just a minute, I will convert that into USD. It's about 6 cents, about 8 cents, 8 to 9 cents, like less than 10 cents. That is a direct cost of production, but this capital and all will come separately. It's about 10 cents.
And one more question, have you ever felt the shortage of raw materials, that is waste in the supply side, from the supply side?
Yes.
Because
Yes.
I just want to give an example. We had some in Nepal. We had some methane production plants, and sometimes raw materials shortage we feel. In that case, so we have to close the plant.
Yes, see, we also face the same situation, because initially the plan was 1,000 tons per day, and then with everything, and then finally the plant capacity was designed and then built for 700 tons per day. Then when the waste delivery happens, due to various reasons, the waste delivery was less than the consumption initially. It was less. So what we did, that the reason is not the data. Actually, they by that time they have adapted this waste segregation. Strictly, they were doing that is this Colombo Municipal Council. They were strictly adhering to waste segregation into biodegradable and non-biodegradable. That is burnable ones. So we were getting burnable ones because they had the facility to this fertilizer facility for biodegradable waste that they are collecting. So the real input was different. Then what we did was, okay, with other the cooperation with the waste management authorities, this way they have provided us with the required amount of waste to meet the daily production requirements. And next thing is we have opened with the permission, we have opened for the certain industries to deliver their segregated municipal grade waste to the facility. And it's a different scheme. So the supply chain was maintained like that, and then there were some issues. There were certain times due actually that is not directly relevant due to the economic situation and then whatever the pandemic and those external factors, waste delivery and the waste production itself was less because of low consumption. So during that time, there was a nearby, there was a dumping area. It was a controlled dumping area, landfill. We checked the waste, and when they were dumping, they have actually what they have done is they have separated the biodegradable and then burnable substances separately. So the burnable substances were there. So when we tested, it was not very old. It has not started degrading, and there was some residual fuel capacity within that dump. So we started collecting from there and then delivering it to the plant to meet the plant requirement. So those are the three strategies we adapted to maintain the this source.
Okay, that's great. And sorry, Madhav sir, we could not hear you. So you have put on one question. Like he has the question: do you have some sorts of idea to make this technology commercially feasible?
Sorry, come again.
Yeah. He is asking about the technology to be commercially feasible. How can we make it?
Commercial, if it to be commercially viable, there should be a minimum quantity. That is generally the typical is it has to be less. Minimum is 350 tons per day. It is required so that it can support one production line, one incinerator. Yeah, of course, it can go even below, not issue. But the investment recovery, if there is subsidies or if especially for that purpose, it should be a government. I mean, not private party will not invest on it unless it is supported by a government. Anyway, total cost, if you can get the total cost, sorry, total cost and other income like carbon credit and cost on landfill, then it's a straightforward commercially viable option, because whatever that you dump into a river or dump into unwanted area, that value, that economic loss is much more than whatever is gained over here. So it's a straight commercially viable, yes. How the real money flow has to be policy, I mean, it should be on policy level. If they can see, the easiest way is you need to charge, you need to have a cost for dumping for ton per ton. They like 5 cents per kilo, something like that. If there is a charge, they will surely will dump. That has a control mechanism. If there is lot of water, higher cost for the supplier. So what they will do is they will give dry waste, as well as they will not dump this construction material and other unburnt material because of the cost. The processing, the plant will benefit because they will get upfront cash, and the other party who is delivering, municipality or private party, will also benefit by dumping their own waste. So that it's a commercially win-win situation for both sides. So there are small things that can be done, and then it's a commercially viable one. And then everybody has to have patience to hold on, because this is a sustainable long-term solution.
So we are coming to the end of the session. Now, I just want to touch upon the last question that you also mentioned, that we can apply for the carbon credits. And have you ever applied or planning to apply for carbon credit scheme?
Yeah, we were in the actually initially we were in the process of doing that one, but it's towards the halfway of the process we could not go ahead because certain criterias we could not meet with the thing. It's very simple. I mean, like you have to submit the documents like 6 months in advance, something like that. Those kind of a compliance, there were issues, but that is only for one carbon credit scheme. But there are so many other carbon credit scheme. I think I don't have the data at the moment, detail. Even after commissioning the plant, during the operation time also there was some discussions, and then application for this carbon credit schemes were underway. I personally, I mean, I don't have the current update on such thing. I'm pretty sure it is implemented, and then maybe at the final stages of discussion with the relevant authorities to get the carbon credit, and then carbon credit, it is viable, it can be done. It is just it is to start in the beginning of the project. Just submit the required documents, and then it's a straightforward process. Very easy. It is straightforward.
Thank you very much, sir. Thank you very much for your valuable time. With this, I would like to conclude today's webinar. Thank you everyone for attending today's session of the webinar. We have listened to an excellent presentation delivered by our distinguished presenter, Mr. Bashura Vijayasundara. His presentation will be available on Shark Energy Center's website very shortly, and you can also watch this recording in the YouTube. We would welcome any suggestions and comments from you for further improvement, plus any suggestions of your interest on which you want to arrange future webinars. We would gladly do that. One more reminder, on coming Wednesday, on 10th of December, we have the last webinar of this fiscal year on the topic realizing potential of emission trading schemes for energy projects in South Asian region. Do join us. We will be happy to have you there. With this, we end the session, and thank you once again for joining us today, all the participants, experts, and our director and SAC colleagues. Thank you so much. Thank you.
Thank you all. Thank you.
Bye-bye.